This is another foundation level question. This is question 4 from the 2023 paper 1. And this question is all about using a circuit that will help monitor temperature. Now you're going to get questions about monitoring temperature using a thermistor, which you should have learned is this symbol here. It's a rectangle with like a hockey stick across it. Or you'll get questions about monitoring light level, and you'll have to use a light dependent resistor or something like that. Okay. So this one's about monitoring temperature, so how temperature changes. So that's the whole question cut up for you. This is directly from the electricity unit. So we should be able to answer most of these things if we've done our home learning and our homework and our revision. So let's have a look. Let's get into it. A gardener wanted to build an electrical circuit to monitor the temperature in a greenhouse. Perfectly reasonable. Which symbol represents the electrical component with a resistance that decreases as its temperature increases? So resistance goes down as temperature goes up is what we want, and we want the symbol. So you should have learnt these symbols. You'll know that one's a switch. This one is a diode, which will allow current to flow in only one direction, in this direction here. Okay, this one is a thermistor, and this one is a variable resistor. So you can change the potential difference. You can change the resistance using this. Now, this is the symbol we put into our circuit when we're doing our IV characteristics. If you remember, we've got those IV characteristics for a light bulb, a resistor, and a diode. Let me just go through those quickly. This one was a resistor directly proportional to, if you've got the current there and the potential difference there. This one was a light bulb, so it's kind of an S shape. And this one was, whoa, this one was a diode, so it goes to a threshold voltage and then goes up. Okay, and only allows the current to flow in one direction. So I'm thinking about all these things. Although this question isn't about that, these are the kind of things that could come up in a question that is given to you on a foundation paper. But this one, let's get back into it, is about temperature and how we can monitor temperature. So we're looking for the symbol for a thermistor, which we know is that one. Okay. Question 4.2, when the resistance of an electrical circuit decreases, so when the resistance goes down, the current increases. So I goes up. Remember, the symbol for current is I. Complete the sentence. Choose the answer from the box. So again, choose one of these 4. Don't make up your own. Electrical current is a flow of, oh, well, I learned that. It's charge. It's just the flow of charge. Electrons flowing around a circuit carry charge, so we can say that current is the flow of charge. We can actually write I equals Q divided by T from the equation Q equals I times T. Q is charge, I is current, T is time. So we could say the current I is the rate of flow of charge, but flow of charge is perfectly fine for this question. That's all they want. Now, question 3 is a 4-mark question. So we're going to need to think about this when we get to it. Let's read the question. The gardener wanted to find out how the resistance of the component varies with temperature. So how R varies with temperature. Okay, so figure 4 shows the equipment used by the gardener. We've got a resistance meter, which has a temperature sensing component. We have a beaker of iced water. We have a kettle, so we can change the temperature of this beaker, presumably, and a thermometer to measure temperature. It says the resistance meter displays the resistance of the component. Okay, so we can get R directly from that. We can get our temperature directly from that. And when I'm doing these plans and talking about measuring things, I'm going to say what I'm measuring with. So I'm measuring temperature with a thermometer. I'm measuring resistance with a resistance meter. I'm measuring lengths with rulers. I'm making sure I get that detail in and not making the assumption that the examiner will think I know it. I'm going to say it for sure. So plan a method the gardener could use to find out how the resistance of the component varies with temperature. Okay, so I'm going to go down here now and show you the mark scheme and show you why you can get these 4 marks, all right? Because all you've got to do is, first of all, say, well, I'm going to put this into the water and I'm going to put this into the water. I'm going to measure what the resistance is with my resistance meter, and I'm going to measure the temperature using a thermometer at that point, at that same point. And then finally, I'm just going to change the temperature by putting the kettle in, or putting hot water from the kettle in. And I'm going to measure the resistance and the temperature again using the resistance meter and the thermometer. So that's basically the experiment. So to put that into words, I'm going to get 1 mark for saying place the component or the thermistor in the water. So placing this component into the water. That's it. Second mark, I'm going to record the temperature using the thermometer. Okay, so I've now got that is in there. I've recorded the temperature, and then I've got to record and measure the resistance using the resistance meter. They put this in brackets, which means you don't have to say that, but let me encourage you to always say it. Okay, so record the resistance using the resistance meter. So that's 3 marks so far, and all you got to do at the end is say, well, what am I going to do next? To get the graph that looks like this, where I've got resistance and I've got temperature, I've got to change the temperature. So this is going 10, 20, 30, 40, 50, in order to then see how the resistance changes. So my last mark is change the temperature of the water using a kettle and repeat the measurements. That's it. You don't even have to have the brackets bits here. So you can just say change the temperature of the water and repeat the measurements. Okay, so there's 4 marks there. Have a listen back over that. See if you can get your head around putting that in a logical order, because often it's just getting your head straight and putting these things in a logical order that's the problem. Okay, on to 4.4. Complete this sentence. Choose answer from the box. Don't make it up. Use one of these. The relationship between temperature and the resistance of the component is what? Is it linear, non-linear, or directly proportional to? Well, if it was directly proportional to, it would be a straight line through the origin there. That's what you get if you got directly proportional to. So it's definitely not that one. Is it a straight line? No, it's not. It's a curve, so it's definitely not linear, which leaves us with non-linear, which is what you need to put in there. Okay. Question 4.5. The temperature of the greenhouse changed from 10 to 30. Determine the change in resistance between these two temperatures. So I'm looking at the graph. I'm going to get rid of the little marks I put on here because they're going to get in my way. But it goes from 10 to 30. So I am going to put some new marks on here. I'm going from 10 to 30. So at 10, I'm going to go up to my graph and I'm going to see what the resistance was, and it's 200. And at 30, I'm going to go up to my graph and I'm going to do some thinking. If that's 50 and that's 100 and there's 5 gaps, each one of these must be 10. So I'm going to 50, 60, 70, 80, 90. And it's actually crossing at the 80 point. So I've gone from 200 down to 80, which is a change of 120 ohms. Okay, so my change in resistance that I want to put into this answer here is 120 ohms. Okay, the gardener builds a circuit that switches a heater on when the greenhouse gets too cold. Use a physics equation sheet to answer questions 4.6 and 4.7. So some years you're given this equation, some years you're expected to learn it. I kind of expect you to learn them because they're easier to get out of your head quickly if you've got them in there in the first place. So the equation that links I, V and P is P equals I times V. Now you can put it in any form. P equals VI. You could even write I equals P over V. You could write V equals P over I. As long as they're correct rearrangements, any of those would get you the marks. This is the way I learn it. I learn P equals IV, so that's the one I use. The exam board often put P equals VI. It doesn't really matter. Whatever you can remember. So that's the correct answer for there. And finally, the power of the heater is 2,900 watts. So there's my P. The potential difference across the heater is 230, which is the mains voltage in the UK. So sometimes you're asked, what is the mains voltage in the UK? And you'd write 230 volts AC. It says calculate the current in the beaker. That's I. That's my current. So I'm going to need to rearrange this equation like I did a moment ago. P equals IV becomes I equals P divided by V. Now, I've done other videos on how to rearrange equations. There's a whole set of those. So look at those if you're still struggling with that. But having got I equals P divided by V, I can then just put the numbers in. It equals 2,900 divided by 230. And if I do that on my calculator, I get 12.6 and some bits and bobs of extra numbers. And that's in amps, okay? Because it's the current. Now, sometimes, again, I said in previous videos, sometimes they will give you amps on the paper. Sometimes they'll expect you to know the unit and put it in as well. But 12.6 is my answer there. And that is it. There's another, 13 marks for that question. That's a big chunk of your paper. And what we needed to know was the symbols. Let me just highlight a few things here to remind you what sort of things we needed to know. We needed to know symbols. We needed to know a definition for electric charge. We needed to think logically and plan an experiment. We needed to know that a straight line is linear. We needed to know that this isn't a straight line. We needed to know directly proportional is a straight line that goes through the origin, and therefore we knew that that was non-linear. We needed to know how to look at a graph and take information from a graph. So you need to practice those kind of things. We needed to know an equation, and we needed to know how to use it and rearrange it. So we needed to know quite a lot, but that's a good chunk of your electricity unit and the sort of things you needed to know for those. This is the answers that the board give us. That's the official mark scheme. You can see those are the things that I've just gone through, but you can pause and have a look at that if you want. And do go over these videos again. I'm going through every question. I will try and get as many done before your exams as I can. So we've got a nice catalogue for you to look over. But go for it. I'll be doing the next question, which is actually common to the higher paper as well. So 5 and 6 on the foundation paper are common to the higher. So that will be one that the higher students can use as well. But I'll see you on the next one.